Hello and welcome to our CP317 presentation. My name is Julian Bergy and I'll be taking you through these first couple slides, mostly talking about our system architecture. Our system was built in Java and is designed to read product and supplier data from two separate files, organize it, and generate a clean, sorted inventory report. When designing the architecture, we focused on three main goals: modularity, efficiency, and reliability. The system follows object-oriented principles and is structured to be easy to maintain and extend, and each part of our system follows the single responsibility principle, which means every component has one clear job, and that makes our system more predictable and easier to manage. One of the key concepts we used in our design was encapsulation. Encapsulation means we keep important data protected inside each class. This prevents outside parts of the program from directly changing values they shouldn't. In our system, for example, product information like ID or price is stored privately and accessed only through specific methods. This helps avoid errors and keeps our data safe and consistent. Another concept we used was abstraction. We used abstraction to hide complex logic and also make the system easier to use. Users of the program don't need to know how we're reading these files, sorting products, or formatting the data. All of that is handled behind the scenes. They simply run the program and get a clean, organized output. Abstraction helps keep the system simple and allows us to make changes internally without affecting how it works on the outside from the user's perspective. Now that we've touched upon these concepts, let's learn about the structure of our system. Our project is made up of four main parts: the product class that handles our product data, the supplier class which handles our supplier info, the inventory manager class that controls the processing and logic of our system, and the main class that runs the program from start to finish. Each part has a specific role, and by following the single responsibility principle, we keep these roles separate and make the system easier to maintain and less likely to break when changes are made.
Hi, my name is Smarn Rane, and I will be taking you through the last few slides. Our system processes data in 4 clear steps. First, it loads data from the supplier file into a supplier object, then places it into a map for quick access. Next, it reads through the product file, places relevant information such as the product ID, price, and quantity into a product object before inserting it into a list. Then, it sorts the list of product objects by product ID to keep the inventory perfectly organized. Finally, it generates a clean report that combines product details with their matching supplier information. Throughout this process, we've built in smart error handling, which will be talked about in further detail in the next slide. Our system was put through rigorous testing to make sure every part of it works exactly as it should. We wrote tests for normal operations, like proper file reading and sorting, but also for tricky situations, like what happens if a price is formatted wrong or if a supplier is missing. The system handles these gracefully, either fixing the issue or reporting it clearly without crashing. This testing-first approach means we can trust our code to work reliably with all kinds of real-world data. Our demonstration will be performed by our last group member, Meyer Suraj.
In this demonstration, I'll be demonstrating how our inventory management system processes supplier and product data to generate a structured inventory file. We have two input files: supplier file.txt, which contains supplier IDs and names, and product file.txt, which includes product details such as ID, name, description, price, quantity, status, and supplier ID. These files serve as the data sources for our inventory system. Next, our project consists of 4 main Java files, each with a specific role. First, we have supplier.java. This class represents suppliers storing their ID and name. After that, we have product.java. This class defines products, including details like product ID, name, price, quantity, status, and supplier ID. Following that, we have inventory manager.java, the core logic of our project. This class reads input files, processes data, sorts products, and writes the final inventory report. Finally, we have main.java, which is responsible for initializing the inventory manager file, loads data, and triggers the sorting and output process. When I run the program, it performs 3 main tasks. 1, it loads supplier and product data from the input files. Secondly, it sorts the products based on their ID for better organization. And third, it generates an output file called inventoryfile.txt, which contains the processed inventory. Once the program has finished running, it will make a new file called inventoryfile.txt. Now, when we look at this output file, as you can see, it contains structured product information, including the correct supplier names instead of just supplier IDs. The data is stored and formatted correctly, making it easy to analyze.
What we've built is a solid working system that meets all the requirements, with clean code that's easy to understand and improve. The object-oriented design means we can easily add new features later. For example, our next steps could be creating a simple interface so users don't need to work with files directly, or connecting to a database for better data storage. The foundations we've built makes these kinds of upgrades easier to implement when needed. And that is the end of our presentation. If you have any questions, please feel free to ask.